So here I've been asked to talk about this first three-year goal of understanding the subsurface geological data, which I'm very happy to do because this literally used to be my territory. I used to be a field geologist, as I said, making geological maps, and I understand very well that geological maps are literally the language of geologists. This is how we can understand and explain what is the nature and composition and structure and history of the rocks that we can often, at least in part, see at the surface, and which can be very difficult to decipher. And to use our data and knowledge of the surface geology as well as geophysical methods to see under the surface at the rocks that are invisible to us, and for most people are largely both out of sight and out of mind. So in drafting this 3-year, we really argued back and forth a lot about exactly where to put this particular goal. Where should it sit? Because as geologists, we all agree that geological mapping and modelling is fundamental to everything else. To understand and explore for raw materials, for example, to improve access to and to monitor groundwater, to be able to develop geothermal energy, mitigating geohazards, and so on. But it can be difficult to explain to non-geologists why geological maps and models are important. They seem a little academic to some, perhaps, at arm's length from our immediate social and economical and environmental concerns. But the truth is that without them, it's simply impossible to serve those needs. No one would argue, I hope, that it makes sense to plan land use, urban and infrastructure development, agriculture and industry, but increasingly, without effective planning of the 3D subsurface, we will be literally trying to apply policy in the dark. Without up-to-date, high-quality data and understanding of the subsurface, we can't effectively achieve our raw materials goals and decarbonisation and water resilience and hazard mitigation and climate adaptation and mitigation and so on. So this is why, after much discussion, understanding the subsurface is right up the front of the 3-year as the first goal under geoscientific data, digital data framework. Right. So as I mentioned, we have excellent geological survey organisations in Europe. Many of those have been in operation for decades. Some of them have been around for more than a century, some only for a few years. We have this wealth of knowledge of the geology of Europe, but much of that work has been done at national level. And what we are looking toward through the research and innovation goals in this 3-year is capitalising on the long-lived collaboration through EuroGeosurveys surveys, through the expert groups that we have, through the practical implementation that we've already done through the Geological Service for Europe project to deliver the pan-European framework that will support sustainable use and management of the subsurface and allow us to further implement European-level policy in raw materials and carbon storage and so on. So the 3-year aims to deliver on these ambitions through a reinvestment in understanding the geological subsurface. And when I talk about reinvestment, it's no coincidence, for example, that those nations with strong raw materials industries, Australia, Canada, South Africa, are those who have long-lived, strong investment in basic geological mapping, surveying and modelling, the work that falls within the mandates of national geological surveys. In this 3-year, we identify 3 key priorities for research and innovation. The first is, as I say, reinvesting in updating of geological baseline information for Europe. The second is moving towards a European-scale 3D geological model And the third addresses new technologies for subsurface investigation and geomodeling. So to look a little deeper into the first priority, reinvesting in geological baseline information. So collection and updating of continental and marine geological data through mapping and modelling requires a continuous commitment. As part of this work, I identify a number of key actions. The first is creation of scientific vocabularies to enable data harmonisation at European level, literally enabling us to speak the same geological language. The second is to establish a collaborative geographic information system platform, allowing effective trans-boundary collaboration, and this feeds directly into the next action, which is creating regional harmonised transboundary data sets. And finally, support for new and improving existing national geological mapping programs. So this is what we have been asked and mandated to do, both at national level, but also now under the Critical Raw Materials Act, and is a crucial foundation for increased strategic autonomy in raw materials in particular, but also water resilience, energy, hazard mitigation, as I say, and more. So the next priority is moving towards a European scale 3D geological model. This involves bringing together the diverse geoscientific data and knowledge we have access to through our community and through future research, geology, geophysics, geochemistry, with the aim and the ambition of building a crustal scale model of the geology to a depth of 5 to 10 kilometres and encompassing European ambition of supporting exploration at depth. So the actions we've identified here include defining common rules for the description of geology, of geological objects. Again, addressing the need to be able to have common languages for us to technically describe and communicate our knowledge of the subsurface. Setting up a common platform to host and query three-dimensional geomodels in connection with our European geological data infrastructure that's already well operational and continuing in its development. Third, to develop a European scale 3D geological model. So building high-resolution 3D, and finally building high-resolution 3D geological models to be able to visualize and understand the interactions between geology and subsurface infrastructure, for example, to understand rock properties, groundwater dynamics, and hazards, and more. And to optimize the use of the subsurface for the many current and future needs, and not just its use, but also its protection and preservation. And the third priority is new technologies for subsurface investigation and geomodeling. So these will help us to build and make better geomodels, combining data types and sources. Actions here include setting up innovative ground-based and airborne geophysical methods in geological surveying and exploration. It includes developing new methods and tools based on geomodeling and artificial intelligence to be able to integrate complex data from different sources. And it includes developing common 3D geomodeling methodologies and research and innovation frameworks to support co-construction of geomodeling solutions and open source toolboxes. So these are our ambitions for the research and innovation needs in understanding the subsurface that will underpin, well, everything else that's in the SRIA, and that will underpin crucial policy implementation, including the Critical Raw Materials Act, the Net Zero Industry Act, the Renewable Energy Directive, and more. Thank you.